this tutorial on limits. Now the question we have here says solve the following. Number 1, limit of f of x equal to 3x squared plus 5x all over 4 as x approaches minus 2. And the second one is limit of f of x equal to 14x squared minus 3x all over 15 as x approaches 1. Now what we are trying to do now is, first of all, to bring out our expression. We have f of x here as 3x squared plus 5x all over 4 as x approaches minus 2. Now in mathematics in general, when you have a function, there must be an independent variable. And in this particular function now, f is a function of x. That means that the independent variable here is x. And the function depends on the value of the independent variables. So as the independent variables changes values, the function resolves to different values. Take for instance, if the independent variable is minus 5, the f of x will have a particular value, let's say value a. When the value of the independent variable changes to something like minus 4, the f of x, that is the function of that x now, will also change to another value, let's say b. When x is now minus 3, the function also changes to another value c, and so on. So as the independent variable changes, the resulting function changes at the same time, since it is a function of the independent variable. So in this particular question now, what we are trying to do is that we have a function whose independent variable is x, and we know that this particular value of x can change at different points, giving us different values for our function. Now we are trying to get the last or final value of this function as this independent variable changes. So since we have that, the limit of this function is what we are trying to get as x approaches minus 2. It means that minus 2 is the final point where the x is going to reach, then it will stop. So the value of x can start from any other negative real number, but that is not our concern in this particular question. So what we are trying to do is that since we know the final point or the final value for x, where x is going to, then we can now try to find the value of f of x that will be at that particular point. So what we are going to do is very simple. We are going to substitute this minus 2 for x in this function. So we are going to have that this limit of f of x as x approaches minus 2 is now going to be 3 into this place we have x now, we have minus 2 there, squared plus 5 into minus 2 all over 4. Now, since we have substituted the x here by minus 2, we are going to find their final values, which will now give us 3 into minus 2 squared is 4. We have plus 5 into minus 2 all over 4. This is going to give us 3 times 4 is 12, plus here times minus here is minus, 5 times 2 is 10 all over 4. Now 12 minus 10 is 2 all over 4, which when we divide by 2, we are going to have 1 all over 2, and that is the answer. So as this function changes, because the independent variable is approaching a particular value, and since we have known the value to be the minus 2 here, we can get the final point of this f of x, which is this half 1 over 2. So what we have done is just to substitute minus 2 or any other value we can have here in any other question for x in this expression. Then we now substitute and do the computation and have our limit. So limit questions are very simple and very cheap. Now the second question says limit of f of x as x approaches 1. The function is 14x squared minus 3x all over 15. So following the same principles, we are trying to get the final value of this function as x approaches its final value of 1. So we are going to substitute 1 for x into the given expression, which is 14 into 1 minus 3 into 1 all over 15. Now 14 multiplied by 1 is 14. 3 multiplied by 1 is 3 all over 15. 14 minus 3 is 11 and all over 15. So this is the limit. 11 over 15 is the limit of this function as x approaches 1. Now the important information we have to understand in limits is this. When the denominator is an integer, just like this 4 and 15, just a constant, we can get the limit as if we are getting ordinary function of a number, because when we have that f of x is something like x squared plus 1, we can be asked to find f of 2. That is, finding the f of 2 is the same as substituting 2 for x. We can have 2 squared plus 1, which is 5. So getting the limit of a function in which the denominator is an integer is the same as solving something like this, ordinary substitution. But a situation whereby the denominator is no longer an integer but an expression, other techniques can now be used to resolve it. Something like L'Hopital's rule, and some other places we can do factorization of one of the expressions. We cancel out before we solve. But in this case, whenever we have a constant as the denominator, just substitute the value of x here for the independent variable, get our final values. See you in the next class.